Once again, we're going to be proving an important geometric theorem, the alternate interior angle theorem. I have multiple videos on YouTube proving things. If you want to see some more, I have put on there the Common Core standard having to do with proofs and how important proofs are for good geometry education. Again, a disclaimer is I'm going to prove these in a general way and not show as much detail as maybe would be required of a student in my class or even another class, but this is it will give you a good idea of the concepts behind proving these. We're going to do the alternate interior angle theorem, and on the alternate interior angle theorem, it starts by saying if two lines or two parallel lines are cut by a transversal. So you're given that you have to that you have parallel lines, and so as I look at this picture I've drawn, I look at it and I just go ahead and identify L and M are common identifiers of lines, and I call those L and M, and that gives me that L is parallel to M, and that's what's given to us here. That's all we have, is that we have two parallel lines given. Now what I'm going to do is I'm going to label some points to help me with this proof, and what I'm going to label are 1 and 2 right here. And then I'm going to go ahead and label a 3 at this point as well, because I'm going to need that. 1 and 2 are my alternate interior angles. That's what I want to show congruent. And then 3 is going to help us to do it. It turns out that this is actually a pretty simple proof to show, and that is because we can make the claim that angle 1 is congruent to angle 3. And the reason that we know angle 1 is congruent to angle 3 is because it is claimed as a postulate that corresponding angles, which remember corresponding angles are two angles that are in the same place when you have a line that a transversal intersecting parallel lines. So the 3 and the 1 are basically, if you think about these two vertices, both in the top right corner. And so they're corresponding, so they're congruent. That's our theorem. And then we also know from an important geometric theorem that angle 2 is congruent to angle 3. And we know that because angle 2 and angle 3 are vertical angles, and so we can claim that as vertical angles are congruent. Now, whenever we run into this situation where we have two angle 3's congruent to two other angles, we can use the most powerful logical tool we have in our toolkit, and that is the transitive property. Now, some teachers may have you flip and make it the angle 2 congruent to angle 3 and have you write it as angle 3 congruent to angle 2, but it doesn't really matter too much. And so we're going to go ahead and use our transitive property. It's like substitution, but because we're talking about congruence, substitution we only use when we have equal signs. In this case, we're just talking about congruence. So we can claim now that angle 1 is congruent to angle 2, and that is because of the transitive property of congruence. And this is a very, very foundational theorem about parallel lines, and many theorems later on rely upon the existence or creation of parallel lines, and whenever you have that, you're going to run into alternate interior angles, and that's a very simple but powerful proof to this problem.